Hi everyone, how are you doing? I hope you're doing fine. So today I'm going to be talking about, we're going to measure. We have a circumstance as you can see on the screen. So we are going to do what we call, it's called data science. So basically data exists to measure the business. And once you have a business, technically what you're doing is that you're having people coming in, or you have people coming to you, and then when they come to you, you want them to stay, and then you want them to keep coming back. So you want people to come to you, and then you want them to keep on coming back, and then you want to give them what they want. So you make them keep coming back, or you make them stay by giving them what they want, or or delivering on your promises. So you make a promise and then you deliver. You make a promise and then you deliver. You make a promise and then you deliver. So in e-commerce right here, the situation that we have right now is that this business, it has customers. These customers, what they are buying from this business is clothes. So the way this business delivers on its promise is that um, they have, like, let's say you book an appointment with them and then you go physically to a shop. When you go physically to their retail store or shop, then they give you someone to advise you, let's say for 30 minutes. So they have a session, like a personal stylist. So when you go home, you can either order from your mobile app or maybe from the website for the clothes that you would have wanted. Now, I believe, okay, we shall not go so much into the customer, but into understanding the customer, let us go deep into the problem that this client has. So the company is trying to decide whether to focus their efforts on the mobile app experience or on their website experience. So they're trying to, in other words, they're trying to ask themselves, in which situations does a person give us money? Is it that when they use the app or when they use the website? In those situations, when do we make the most money? Is it from the mobile app or is it from the website? So that's what they're trying to do. So we're going to use a technique which is called linear regression. It's a model. It's just a technique called linear regression. So what we do is that we start by, I'm going to be taking you through it step by step, step by step. Now, we're going to find out, when do we make the most money? When does our client make the most money? Is it when the customers choose the clothes that they want from the app, or when they choose the clothes they want from the website? So we're going to find out using a technique called linear regression. So what you do is that I already have a folder here prepared. You don't need to know all of this. I'm supposing that my audience is a business audience, so they don't need to know so much of the tools that I'm using. So what I do is that I do come here and then I start a new file. It's called a Jupyter notebook file. So I'm going to, don't mind about this if you're not very technical, if you're not like so much of a very technical person, then I'm going to give it a name. Okay, what we do is that we do have something in a computer language which they call libraries. Libraries are smaller programs that were written by other people that help us do the work faster. So here we're using the language called Python, but if you're in business, you don't need to know Python. So we're going to these are called libraries, but you don't need to stress yourself with this. Import. So import pandas. If you're in business, you don't need to. If you're technical, then you need to know this. I'm going to also import matplotlib. I pyplot SPLT. Then I'm also going to import machine learning model. You don't need to know. It's called sklearn. So this one has models that were already created by other people. Then I'm also going to import Seaborn. Seaborn is a Python library that helps us create graphs. So after that, I'm going to run. I'm going to, so this is a Jupyter notebook, so I'm going to run. So it shows me that it has run successfully. So after that, I'm going to get this data set. Now, since this is just a project, the source of data here is Kaggle. It's an online resource. But when you go into businesses do have, let's say, their sources of data. We have relational databases. We have data warehouses. Those are in the, okay, sometimes they can be at the office premises or headquarters, or they could be they could be in the cloud by different cloud providers. The cloud providers, if you want to know more about this, there's the most prominent one is Amazon Web Services. We have Google Cloud. We have also Microsoft Azure. So some people call it Azure, other people call it Azure, other people call it Azure. So Azure, all names work. So the data source that we're using here is an online resource. It's called Kaggle. You could go and find it anywhere that you want. Not anywhere that you want, but you could find it on the internet. So when you find on the internet, type in kaggle.com, you are going to find very many data sets. But here we are in the domain of commerce. So there are different domains. There's insurance, there's retail, e-commerce, there's transport. There are very many. So what we do is that we download it. I'm going to download it as a zip. So go to my downloads right here. Then I'm going to unzip it from here, of course. And then extract it. Extract it in the same place. Then after that, since it has not come in the way that I want, but it's fine, shall deal with that. So I'm going to put it into the working directory that I have in my development environment. If you're a very technical person, you can understand the term. If you're not, if you're from business side, you don't need to know the term. It's okay. So I'm looking for my environment where I'm going to calculations from quad projects. Project. So it's right here. So I'm going to put it right here now. So I put it right there. So after putting it right there, so what I do, this side it's going to reflect. I'm sure it's going to reflect. Yeah, it has reflected. So it's a CSV. So if you look into it, it's a CSV file. Comma separate. It's CSV stands for something like comma separate. It's a comma separated file. So what I'm going to do, I'm going to rename it. So I'm going to rename it and give it a file type. It's of a CSV, like that. Then I'm also going to save this. I think we save it by closing it. Then I'm going to save it as okay. Let me create a new file and then let me call it linear regression notebook, Python notebook, like that. So I'm going to copy this, I'm going to copy this, and put it in this file, paste it right there. It's supposed to be called. Supposed to. So I haven't selected the kernel, that's why it's doing this. Not understanding. So now it was understood. Then I put paste. Then I must run the code to get rid of that. I don't save it. So I have now two files. I have the data, then I also have the notebook where I'm going to do all the calculations, I'm going to see all the calculations and how we're moving forward. So what I do this. I run it. So when I run it, it goes. So now it's trying to pull all those programs and then put it here in one place so that when I'm working with a program or maybe with a file that I'm writing right now, I don't have to write a lot of code to do what I want to do. So next, after having these other programs, the code libraries, they help me do work faster. Let me put it down in writing. Let me document because this might be presented to someone else or maybe someone. So documentation is very important. Let's say we are working in a team. Someone needs to know what I was trying to do. So I come here and say introduce. So this is a markdown. You don't really know what a markdown is if you're not that technical, but it helps me document. Introduce the CSV file. Go to the Jupyter notebook like that. Be like, good. Okay. Now we come and then we now want to pull the data into the notebook. So what we do is that we give it a name called df. Inside this file, we're going to call it df. There's a library, it's called pandas. So we're going to say remember we installed we brought in pandas as pd. So I'm going to say pd. I'm going to tell it to read. I'm going to tell it to read the CSV. So after that, I'm going to give it the file. The file is customers. So it's got to see CSV. And I'm going to run the code. So now we have our data now inside here. So of course we must take a look at the data that we have gotten. So what we're doing right now, people call it exploratory data analysis. What you're trying to do is you're trying to study the data that has been given to you. You're trying to study its properties. You're trying to see which data can really give us the outcome. But I'm going to keep on reminding, as we're doing this, remember the client or the business wants to know where it can focus its efforts. Should it focus its efforts on the website experience or on the mobile app experience? Because when you're in a business, resources are limited. The developing team, you must pay for that developing team, or maybe the time to develop, time to market must also be very fast. So you need to focus where you should put your strategies. Time is limited. Everyone only has 24 hours in a day, and then also we do have money is also limited. If everyone had money, then if everyone had unlimited money, if business had unlimited money or budgets, they would not really do this. They will not be measuring every nitty-gritty. But we do this because we must deal with the resources that we have, and then we're able to achieve the most and get a profit. So then we take a look at what's inside the data that we've gotten. So take a look. What? See and see. Looks inside. So we do that by we give the computer a command and say it's called df head, like that. That's what we do. So we play. So here we're going to see the data that we have. We do have the email of the client, the address of the client. These locations are British. The avatar or the client, the name of the avatar is who? It's violet. We have dark green. We have biscuit. We have saddle brown. Then the average session length, the time that they spend with the personal stylist when they come to the shop. So the average session length, this one is 34 minutes. Time on the app, that's showing 12 minutes. Time on website, 39 minutes. Length of membership. Length of membership is how long they've been with us. And showing 4 months. Then yearly amount spent, the amount that they really give, the money that they give us. So it's showing £580. Okay, so after that, so after that, we're going to look at now the statistical, in a statistical view. So we come and say df.info. Now this one helps us. I won't show you how. So df.info, it shows us this. It helps us understand the data that can be measured in numbers. So the time that they spend with the stylist, the time on app, time on website, length of membership, all those are floats. So we get to see the data types. So email, that's an object, that's a string. And then for the time on app, that's a float, that's a number. So this helps us that in case, let's say, it helps to know what kind of data that you're dealing with. Are they words or the numerical ones, or it's data that is made of numbers. So the other thing that we do is that we look at the statistical analysis. I'm going to explain statistics like df describe like that. So when we play, so we look at all the things that can be measured, all the factors that make someone give us money and the money that's spent. So on average, yearly, for every customer, we make £499 right here. Then it differentiates a bit by £79 for every customer. So the minimum we can make is £256. Then in the 25% quartile, let's say 25% of people, of our clients, they give us £445. 50%, half of them, they give us £498. Then 25%, and then 50%, then 75. So those quartiles. So people who are less than 25%, they give us that. 50% give us that. So we have lower, middle, and upper. So the upper customers, the high-end customers, they give us £549. The average customer we have, then the maximum amount that the maximum money that we have gotten from a customer, that we get from a customer per year, the maximum that we can make is 769. That's the maximum we can make. So yeah, so it shows here we have data types, we have float, and then also strings. So that's quite good. We are going on with the exploratory data analysis. So here we are seeing which thing makes us more money. Which thing do we do that makes us more money? Remember, we are trying to focus on the experience. Should we focus on the time on the app or should we focus on the time on the website? So we do exploratory, explanatory, explore. Okay, we are exploring uh, analysis. So let's start by figuring out if someone spends more time on the website, that will then give us more money, or when they spend more time on the website, do they give us more money? So we do that by, let me show you. Let's start by finding out if um let's find out if uh, client spends more time on the website. Does it make it? Uh, does uh, do we make money? Do we make money? Do we make money? So we do that by getting a graph and then we are showing the relationship. If someone spends so much time on the website, so we do that by, let me show you how we do it. So we use a library called CNS. I'll use a graph called joint plot. Then the x-axis is time on website. Y. So the y-axis, that's the target. That's the target. Then the x-axis, that's the dependent variable. Depending on the time spent on the website, do we make more money or we don't? We're going to see in a few seconds. So yearly amount spent. So the data I'm going to use is inside something called the like that, yeah. So I'm going to print it out. So now you see time on website. It's not giving us something very well, but let me make it more clear. So I'm going to say alpha equals 0.5 like that. So alpha equals, so you see the more dots that appear on top of another dot, the darker it becomes, but before it was not like that. So you make it to be like that. So we get to see that people do spend between 600 and 400 pounds. And then people get to spend, the person spends at most 37 minutes. So our clients spend 37 minutes on the app. But it's not, but them spending 30 minutes on the app does not really show that that they do what? That they give us money. So what we do, we found out that that's not true. Website doesn't make us more money. So we don't see much correlation here. So what we do, let me just write down. So, um, in the above relationship, we do not see much correlation between the two, between someone, someone spending time on the website and giving us money. So, what about time spent on the app? Let's do that. What about time spent on the app, on the mobile app? Let's see if someone spends time on the mobile app. Let's see if it makes us money. Hmm? So, just like I did in the other app, I'm going to use the Seaborn um, package, create a joint plot. X, if someone spent time on the app, do we make more money? If someone spent time on the app, do we make more money? So we do that by doing this. Say time. We say time on the. We say We set time on app. Set time on y. Y is equal to. If you're hearing some noise, I'm going to edit them out. And amount. Really amount. Sorry about that. So would be like data equals df alpha equals 0.5, alpha equals 0.5. So we're trying to see and be like, if someone spends time on the app, like, will they give us money? Like, do they give us money literally, or do they really give us money? So we're going to do that and be like, actually, kind of, yeah. When someone spends time on the app, so you see, there's a kind of correlation. So it's going like this. The more time someone spends on the app, the more money. The more time, more money. The more time, more money. The more time, more money. Like that. So this is actually good. So I think we have already found our answer that the client or the business should focus on the experience of the app instead of the website. That's where they should focus their time. That's where they should focus their resources and money. They should develop the app better, make it look better, make it fast, because when someone spends more time, that's when they release more money. Now, we have found out that actually, um, the above graph shows that um, the more time someone spends on the mobile app, the more money we make. Okay, so we have seen that we have compared only two things: time on the website, time on the app. So what we do is this. How about if we compare all things at the same time? We're going to see the strongest thing that makes someone give us more money. So let's compare uh, other things or other variables and see uh, what makes us money most. So I do that by comparing all the variables to what? To I compare all the variables against each other and see if there's a correlation. So what we do is this: we come here and say CNS, pair plot, give it the data it needs. Then the kind of graph, it's going to be a scatter plot. And then, um, so, okay, like KWS means like the intensity of the colors of the graph. How are they going to appear? So intensity means that if there's a dot on top of another dot on top of another dot, it's going to appear in a thick color. So it would be like alpha, like that, 0.4. And then uh, we run the command. So we are comparing each variable against each variable. We're going to see which variable is the strongest. So you see here, let me start down. Average session length, the time that the client spends with the stylist and the money that they give us doesn't really matter. When the client spends more money, when the client spends more time with the stylist, it doesn't really make so much money. When the person spends time on the app, yeah, you see the dots are kind of, but not so much. Time on website, not so much. Length of membership. So the length of the membership determines how much money someone's going to give us. The longer someone stays with us, the more money that they'll give us. So it's very important for businesses to make sure that customers stay with them. It's a recurring business. Those are the best businesses that someone recommended when I was somewhere. You need to have a business where someone comes back to you. Someone keeps on coming back to you. That's a school. Those are food and beverages. We're talking about alcohol. We're talking about juice. E-commerce. Let's say body products like Vaseline. Like someone will keep buying. So the longer someone stays, so it means that what you're selling must be very good. But that's for another discussion. So we're seeing that really, the longer someone stays with us, the more money that they give us. So the length of membership. So that's very, 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 very important. So we are going to really dig deeper into this because we have already understood, we have already answered that they should focus on the experience of the they should focus on the experience of the app. That's the action that they should do. By now, let's over deliver and show them more. So what we're going to do is that what we're going to do, we're going to look at this thing closely. So let's look at it at a better graph. So we have we have seen that um, if someone stays with us in membership, means that they give us more money. Let's look at it very well for the demonstration. So, Ibon, I'm going to plot the x-axis. If someone stays, do we make more money? We're going to look at that one more. Um, the variable is ship y equals to um, the amount spent, comma, data equals to df, and then how thick do I want the things to be? Give it 0.3, like that. So the strategy has already been answered. Focus on the mobile app experience. So here you see 1 month, 2 months, 400, 3 months, 7 months, more money, like that. So you see those dots, they're kind of coming closer to that line. The perfect thing would be all those dots to be in that line, but you see they're all coming closer to that line, which is very good. The closer they are, the better that we are at predicting. So we are going to predict more. We're going to predict how, let's say, we're over delivering. Now, this regression can be very important if, let's say, you want to invest in, let's say investors want to invest in the business, or maybe you want to take on a loan because you already mastered and know that these people will stay, and you want to expand it. Maybe you want to take more loan, you want to take more clients, or maybe so since you've known that you can focus on the since you've known that you can focus on the mobile app experience, it means that they'll stay. So you want to make more people stay. So what you do is that, let's say you want to invest in marketing and so on. So now you want to put this business on fire, make it so hot, start printing money. You want to know how much money you'll be making and in the future. So to predict how much money we're going to make in the future, we have already achieved the objective of the project, but here right now we're just over delivering. So we're trying to predict how much money can we make in this. So we have known that if someone stays, if we have known that the more someone stays with us, the more money we are going to make. But we want to invest in acquiring more clients. So we want to know how much money we shall invest when we acquire more clients. But we want to invest in getting more people, but we want to know how much money we shall make when we get more people. So, the longer someone stays, the more money. The longer someone stays, the more money. So, we'll show you. We'll show if what we are predicting is actually like really right. So, come here and be like, okay, basically land, let's say, model selection, brain, test split. So we're going to divide our data. We're going to have some data um, broken off. Some data we're going to use it to train, and then after training the model, and then we shall test that model against the data that we have. So we do that by, let me show you what we do. X-axis equals to EF, that, and then VG, and up, website, and so membership, Y. So we get all the time, all the data that is in numerical. We put it into a data form, yearly amount spent, and then we're giving that data new variables, and then we're going to, just a moment, something that's happened. Okay, so yeah, that does happen. So what we do is right here. So we're dividing that data into extreme x y grain equals to, so we're splitting it now. So we're saying x, y, test size, that is 30% of our data. We're going to use it to test. Then the rest is going to be for training. Test size equals to 0.3. Random state, our values better be random. The predicted numbers the predicted money that we get better be random. So of the data that we have, we are taking 70% of it to train the model. So what we're doing is that now we run this. Just a moment. Sorry, I didn't run this. we're now good. So we have now split the data, and then now the next thing that we're doing is to train the model. So training the model. We're going to use a model from uh, plan justify from package that has been machine orders. So we import the linear regression. So from the line, linear regression, and then plus linear regression like that. So we have imported the model. So now we're going to fit our data inside that model. The next thing we do is this. We say lm dot fit. Now we train the model. The xtrain, same data, xtrain slash y train. Now, tada. So we have trained the model now. After training the model, uh, we're going to see which variables are really important in determining the money that we make. So we do that. Let me just write down the. So we do that by saying is we do that by there's something in mathematics called the coefficient. So the coefficient, let me say this f d. So now we have trained the model. Now I want to see which thing really makes us the most money again. I want to be sure. Coef slash expect coins. So if you look at this, and so you see the question that they had for us, the business had for us, um, they shouldn't really even focus so much on the website because see, it does not determine how much money we make. But on the app, that's where we make the most money. Then we should also make the people stay longer. So in predictions, it'll be like this. So in predictions like that. Let me put a variable called prediction. So predict. So we are now predicting and be like, okay, we have, what if we predict and be like, okay, let us now test the X, remember the X that we had? So we have trained. So now it has the numbers that we have. Let us look and see and get the predictions that we get. Okay, what do we get when we let me show you how much money we make. Printed. Like that. So um, this is the money that we predict to make if we continue with this trend. Because what we are saying is that we broke down the data that we had, trained 70% of the, the X, and then remained with 30% of the test size. So now we're testing the data that we have with the one that we predicted. So we have the one that we trained. So we have trained the data, and now we're telling it to predict how much money we make if we continue on the trend that we have been making. So let us evaluate and see that the predictions that we have made, are they right? Are they right? So we do it like that. Let me show you. We do it like this. So the question is the money that we have predicted almost similar to the money that we have made so far? That's a question. So one way to find out, we say we create a graph, call it upload predictions. So the predictions we have over the y test like that. T dot label predictions. X label is going to be predictions, and then so we are seeing that the money that we've predicted, does it almost be equal to the same that the money we've made so far? We want to make sure that our predictions are right. Title, evaluation of our linear regression model. Let me confuse some people. Let me make it there. Linear regression model. So let's go. Sorry about that. So we find that the money we predicted versus the money we've made, they're almost coming to the same. So our predictions are almost right, but we're going to see how right are they, like the methods that we used to do that. So we need to measure more because people are going to put in money. We don't want to make false predictions and then money is lost. Then another measurement, we have metrics that we use. Let's make uh measurements and see. So from sklearn metrics, what mean square error, mean, okay, I think that will be enough. So let's go ahead and do this. Print squared error, that, so error, test, predictions, then print uh, squared error, that, error, test, predictions. Okay, it's good. Then we run and then we see we have some error. Just a spelling error. It's just a spelling error. So we come and make it right here. Up, 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 up. Run it. Oh, series attribute has no. Okay, let me make it better. Something. Yeah, this was just this. So we have run. So, okay, this is absolute. Absolute. So it means for every prediction that we make, we are off by $8. £8. Sorry, because this is a British. But then mean squared error means that for every error that we have, we must make it bigger. So let's say you have a basket and then there are apples inside that basket, but then we don't tell you how many apples are inside that basket. We just tell you to guess. Let's say you mention 5. When you mention 5, there are 4. It means you missed by 1 apple. Now, let's say there are very many baskets of apples, over like 1,000. So we shall take all those errors that you've made and then we get an average of those errors. So we find that we have missed almost by £8 for every prediction that we've made. So that's very good. So The mean squared error is, let's say, 103 pounds. So far, the demonstration of this has been, so there are very many use cases for linear regression models, very many. So I beg to stop here. I beg to stop here because the video is kind of like taking long and then looking very long. So I need to stop here. So till we meet, you can pass on this video to someone next, or maybe you can subscribe to my YouTube channel, or maybe you could share this video with someone whom you think it would be helpful too. Thanks and stay blessed. Yeah.